Welcome to the Day 5 video, which covers optimization with linear programming. So we're going to be looking at two problems today, starting at problem 1. You are given the graph of the constraint inequalities. Use a table to find the minimum and maximum values of the objective function. Okay, so there's a lot going on here. What you're first going to see in the graph is you're going to see this shaded region. Here's how we got that. There were 4 inequalities that were drawn. Here was the first one. Here's the second one, here's the third one, and here's the fourth one. Now, we don't have the equations for them, or the inequalities for them, but when those inequalities were graphed, the shaded region is where all of their shadings overlapped. Okay, so those are what the question is referring to by the constraint inequalities. So we don't see the actual inequalities written out, but we can see the result. Now what we need to do is we need to find the minimum and maximum of the objective function. This is the objective function right here. So we want to find the minimum and maximum of this function within the shaded region. Now a key idea here is that the minimum and maximum is always going to occur at one of the vertices. So it's not going to occur at just any point in the shaded region, it's going to occur at one of these vertices. So here's what we're going to do. We're going to make a table. On one side of the table, we're going to list out all of those vertices. So we have that 0.06, we have the 0.27, we have the 0.00, and we have the 0.50. Our objective function is x minus y. So what we're going to do now is we're going to calculate x minus y for each of those points. So for the first point, 0 minus 6 is going to give us -6. We then have 2 minus 7, which will give us 5. 0 minus 0 will give us 0, and 5 minus 0 will give us 5. This one should be a -5. Okay, so ultimately what we want is we want the maximum and minimum. So our maximum, our highest value is 5. Our lowest value is -6. Here's the way that you would express that. You would write the maximum is 5 at, and then you have to list the point, 5, 0. The minimum is -6 at 0, 6. Okay, so for the next type of problem, you're not going to be given this graph, you're going to have to come up with the graph. So if we look at example 2, it says, sketch the graph of the constraint inequalities. Label the vertices, then use a table to find the minimum and maximum values of the objective function. Okay, so we still are given that objective function. This one is going to require some more work because we're given the constraints, but we have to graph them. So that's what we're going to do now. We're going to graph those constraints. This is a continuation of what we've done in class. So x is greater than or equal to 0. It's going to be this line right here. It's really important that you use a straight edge. If you don't use a straight edge, you're going to run into some trouble, and I'll show you why in a minute. Greater than, we're going to be shading to the right. So I put little arrows to show that that's the direction I want to shade. Next one we have is that y is greater than or equal to 0. So that will be this line right here. Greater than is that up direction. And then last one that we have is that 2x plus y is less than or equal to 6. So this is in standard form. In class, we've been telling you to create the xy chart. I know some of you like to solve for y. Most of the time, it's going to be easier just to create the xy chart. If I put a 0 in for x, I get y equals 6. If I put a 0 in for y, I get x equals 3. So the 0.03 is right here. The 0.06 is right here. Again, use a straight edge. Don't just guess on the shading. Plug in a point like we've been doing. If we plug in the origin, we get 0 plus 0 is less than or equal to 6, which is true. So we want to shade towards 0. Okay, so ultimately we're looking for where all those shadings overlap, which is going to be this triangle. Please do not guess. Some students like to think it's always going to be the triangle. It's always going to be the closed figure. That's not the case. So you need to consider each inequality separately and figure out where all the shadings overlap. So now we're at the point that we were at in the first problem. We need to find the maximum and minimum. As I said with the first problem, the maximum or minimum isn't going to happen at just any point. It's going to happen at one of the vertices. So in this case, we have this vertex right here, we have this vertex right here, and we have this vertex right here. So what we're going to do is we're going to create that same chart. On one side, we're going to put the points. On the other side, we're going to plug them into our objective function. So one of the points is 0, 0. One of the points is 3, 0. And one of the points is 0, 6. If I plug 0, 0 in, I just get 0. If I plug in 3, 0, I have 3 times 3, which is 9, minus 0, which will give me 9. If I plug in 0, 6, 3 times 0 is 0, minus 6 will give me negative 6. Now we need to look at what we're asked for. We are asked for the minimum and maximum values. So we would say the maximum is 9 at 3, 0. So you always have to say both, what the maximum is and where it occurs. The minimum is negative 6 at 0, 6. Okay, so where are we going with all of this? If you look to the next page at this fundraising problem, we're going to be doing this problem in class, but I want to give you an idea of what we're doing. With these problems, you're going to have a word problem. You're going to have to write those constraints. You're going to have to write the inequalities. You'll then write an objective function. And then you will graph it. And you will come up with either the maximum or the minimum, whatever you're looking for. So when you come to class tomorrow, please be prepared to do this problem together. If you have any questions, please make sure you ask.